Hi, welcome to today's class. This is the first of a three-part series on whole numbers. At the end of the lesson, you should be able to express any whole number in standard form. 2. Express any decimal number in standard form. 3. Find the prime factors of numbers not greater than 200. 4. Express numbers as products of its prime factors. Let's get started. The concept of whole numbers is not new to you, as you have been learning about it right from primary school. In this lesson, we will build on your current knowledge by learning how to express numbers in standard form. It's easy to express whole numbers like 1,000, 1 million, 1 billion as powers of 10. For example, 1 million is equal to 10 times 10 times 10 times 10 times 10 times 10, which is equal to 10 raised to power 6. Generally, to express any number in standard form, you must express it as a number between 1 and 10, multiplied by 10 to a certain power. For instance, we are asked to express 2,500,000 in standard form. We know that 2,500,000 is 25 times 100,000 or 25 times 10 raised to power 5. But 25 is not a number between 1 and 10. Therefore, to convert it to a number between 1 and 10, we move the decimal point to the left by 1 place and then add a single 0 to the previous exponent of 10, making it 10 raised to power 6. Note that the power increased from 5 to 6 because we moved the decimal point 1 place to the left. Therefore, 2,500,000 is written as 2.5 times 10 raised to the power of 6. Let's see another example. Represent 8,900 in standard form. This is simply 8.9 times 10 raised to power 3. Great! Decimal numbers can also be expressed in decimal form in the same way large numbers are represented. The only difference is in the sign of the power or the exponent, which in this case is negative. The general rule to follow when expressing decimals in standard form is to move the decimal point to the right until it passes the first non-zero value. Now let's see some examples of this. 1. Express 0.008 in standard form. To solve this, we move the decimal point to the right until it passes the non-zero value, which is 8 in this case. Next, we count the number of times we moved, and that will be our negative exponent. In this example, we move the decimal point 3 places to the right. Therefore, the exponent is 10 raised to power minus 3. Hence, 0.008 is written as 8 times 10 raised to power minus 3 in standard form. Example 2. Express 0.0135 in standard form. Like the previous example, we move the decimal point to the right until it passes the non-zero value, which is 1 in this case. Next, we count the number of times we moved, and that will be our negative exponent. In this example, we move the decimal point 2 places to the right. Therefore, the exponent is 10 raised to power minus 2. Hence, 0.0135 is written as 1.35 times 10 raised to power minus 2 in standard form. Moving on, we are going to be learning about prime factors. Do you remember what prime factors are? Prime factors are factors of a number that are themselves prime numbers. A prime number is any number that can be divided by 1 and itself. A prime number has only 2 factors, 1 and itself. Examples of prime numbers are 2, 3, 4, 5, 7, 11, etc. Prime factors of any number can be found by prime factorization. Prime factorization is a method of finding prime numbers which are multiplied to find the original number. For instance, 6 can be written as 2 times 3. Let's try some examples on prime factorization. Express the following as products of their prime factors: 1, 24, 2, 120. Starting with the first number 24, we'll use the ladder method to find the prime factors of 24. We start dividing 24 by the least possible prime number that can be divided by it, which in this case is 2. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. At this point, we move on to the next prime number, which is 3. 3 divided by 3 is 1. Reaching 1 signifies the end of division when using the ladder method of prime factorization. Therefore, 24 written as a product of its prime factors is 2 times 2 times 2 times 3. The second number is 120. We'll use the same ladder method to find the prime factors of 120. We start dividing 120 by the least possible prime number, which in this case is 2. 120 divided by 2 is 60. 60 divided by 2 is 30. 30 divided by 2 is 15. At this point, we move to the next possible prime number, which is 3. 15 divided by 3 is 5. 5 divided by 1 is 1. And we're done. Therefore, 120 written as a product of its prime factors is 2 times 2 times 2 times 3 times 5. Good job! With this, we have come to the end of the lesson. Today we learned how to express whole and decimal numbers in standard form. We also learned about prime numbers and prime factorization. See you in the next lesson.